arguing, so there's that. So, it does matter the order that you do things. You don't just throw together a peanut butter and jelly sandwich. You take out the bread, then you put peanut butter on the bread. I particularly put peanut butter on both breads and the jelly on the inside. Anybody guess why I do that?
So it sticks.
So it doesn't come seep through the bread.
Yeah, the jelly will like seep through bread.
Alana gets it. You get it.
Or you could just get Smuckers.
I don't like. No.
What? Goobers are good.
I do not like when the jelly soaks into the bread. It makes it really soggy. Not a fan. So whenever you think of permutations, the order does matter. A combination is like a smoothie. When you make a smoothie, you take out a blender and then throw everything in that you want and then you blend, right? The order doesn't matter. It doesn't matter if you put the strawberries on the bottom or the bananas on the top. It does not matter. So a permutation, the order does matter, like in a peanut butter and jelly sandwich. So some situations you might see on these problems, because some of them are actual words, you'll definitely see the word arrange. So I would write that in. You will see the word arrange. Because it's not going to say this is a permutation, this is a combination. It's going to say arrange these objects. Okay? Here are some scenarios that you might be arranging. Teams can place first, second, and third, so we just did that. First is obviously different than second and third. Students will be chosen to be president, vice president, treasurer, chaplain, and secretary. If I were picking you at random, why would it be different to be president than to be chaplain? There's just a title. It's a different job, different position, okay? Different requirements, okay? Placing items on a shelf. This one, let's say, how many books do we want to have?
None.
Let's happy medium. Let's do 6.
That's
we could do 7. That's fine. 1, 2, 3, 4, 6, 7. Well, she said 10. That's fine. So, when I'm putting books on a shelf, how many do I have to choose from to put my first book?
1.
How many books do I have? 7. So how many do I have available to put in this first spot? 7. I use 1. Is the one that I use in the first spot going to be used in any other spot? Is that possible? No. So how many do I have available for the second spot? 6. And for the next one? And the next one? And the next one? And the next one? And then there's 1 option left. So basically, this leads to the next thing. This is called a factorial. This is the same thing as 7 and a little exclamation point. If you saw this on your SATs, which you did because you all had the same SATs, the exclamation point means a factorial. It means you start at that number and then you multiply all the way to 1. So 10 factorial would be 10 times 9, 8, 7, 6, 5, 4, 3, 2, 1. That make sense? So you're going to see that a lot in this section. This would be a permutation because once you use an object, it cannot be in 2 places at once. Okay, so the arrangement of that matters. And the last, choosing the order of who presents a project first. Let's say you all did a project. If I picked Noah to go first, could he possibly go third? If he's already presented it. No, you're not going to present twice. So once you've been used, you can't be used again. So this would be a permutation. Okay, so there's your peanut butter and jelly sandwich. So this brings us to a factorial. So anytime you see this exclamation point, you're going to start at that number and then go all the way down. So starting at 6 factorial, what would that look like?
6 times 5 times 4.
That's a spot on your notes, by the way. Times 4, times 3, times 2, times 1. I said to everyone. All right, so what is 6 times 5 times 4 times 3 times 2 times 1? It is definitely not 30. Okay. 6 times 5 is 30? No. Times 4 is 120. It's 720. 720.
720.
But it's not possible. 30 times 4 is 120. Times 3 is 360. 360 times 2 is 720.
That's robotic.
Yes, sir.
So say if it's like an 8 in the exclamation.
So you do 8 times 7
Yeah,
times
I
6.
know. Can you do like 180 times 8 and get the same number?
No. Where are you getting 180 from? Is my question.
6 times 180 is 720. No, it's not. Is it? Wait.
Is it? I don't think so. I think it's
My brain. Hold on.
No.
6 times what?
180.
6 times
4 times 180 is
80.
Okay.
no. So you can't. I would not do that. The second thing you want to write down, please focus. I need you to write down 0 factorial is 1. So it's highlighted for you. 0 exclamation point is 1. It's one of the weird rules. Like when you see 5 raised to 0, what is that?
What did you? I don't even know.
5 raised to 0.
Oh,
1. It's just a weird rule like that. Okay? Can I explain that to you? Not really. It's an odd rule. So anytime you see 0 factorial, that is 1. Okay? So, you're going to write in this formula in the big blank space under the peanut butter and jelly sandwich. You want to write down NPR and then all of this as well. And I'll explain all of it. Color-coded and everything. All right, so N stands for the total number of objects. So I'd write that in, total number. So if it's the total number, could the right number be bigger than the total number? No. If the total number should be as big as it gets. Letter R, that's how many places there are. So letter R. That will represent how many places there are. How many places. That could include first, second, third. That could include president, vice president, blah, blah. That could include how many places on the bookshelf. Okay? Yeah. So there was 7. So 7 books, 7 places on the bookshelf. So that one would look like that. So anywhere you see an N, you're going to plug in the total number. Anywhere you see an R, you're going to plug in the smaller number, how many places there are. So we're going to do the first one. I'm going to go ahead and write down the formula. N factorial over N minus R. So all we're doing is writing down the formula so far. You're finding how many permutations there are. There are 6 total things.
I got that, but why is there a second fraction?
Because I'm just going to plug them in. So what does N represent? 6. So I'm going to plug in the number 6. So I wrote it because I'm going to fill in. And N again, so still a 6. And then we have R, which is 2. That's why. All right, so what do we think we do next? I would not be typing anything in because I'm going to try to make this easier for you. The parentheses, what is 6 minus 2? 4. Well, realistically, the only people would be Algebra 2 students. How many of you are in Algebra 2? Okay. So you've already done this week, I'm sorry. All right, so here's what you cannot do. What does 6 factorial represent? 720. 6 times 5 times 4 times 3 times 2 times 1, right? What does 4 factorial represent?
Not 720.
Not 720. It doesn't represent the same thing. So you cannot say, oh, they're both divisible by 2. Let's reduce it. That's not what happens. What you can do, 6 factorial is the same thing as 6 times 5 times 4 times 3 times 2 times 1. But instead of writing it all out, you could stop at 4 factorial. Because what does 4 factorial represent? 4 times 3 times 2 times 1. What do we notice when we stop at 4 factorial? Yeah, on the bottom it matches. So we can cancel them out. Because they represent this same number. I know, you multiplied all of the numbers out. Yeah, you just did a lot more work. It's fine. It's just a lot more work. And then when the numbers get bigger, like that's 8 factorial, it's going to get bigger. Anyways, so then the 4s will cancel out. All you have left is 6 times 5, which is 30. So our final answer is 30. All right, we're going to do the same thing on the second. N factorial over N minus R. Eventually, I'll stop writing it in. All right, so what am I going to plug in for N? 8. So N will be 8. And then R is... It is 5. I think you were just working ahead. 8 minus 5 is 3. So the bottom will have 3 factorial. The top has 8 factorial. So over 3 factorial. So what do I want the top to match? The bottom. So I want to stop at 3 factorial. So 8 times 7 times 6 times 5 times 4 times 3 factorial over 3 factorial. So those cancel out, and all you have left to do is 8 times 7 times 6 times 5 times 4. Yes, ma'am. And sir. 6,720. Perfect. All right, so these are 2 special cases. We have 7 permutation 0, 3 permutation 3. So it's going to be the same thing. We'll try to skip ahead a little bit. So what's going to go in the top? 7 factorial. And then the bottom will be 7 minus 0. I've seen a lot of people get 7 minus 0 wrong. What is 7 minus 0? 7.
1? What? 1?
You alright?
So what is anything over itself?
1.
So our final answer is 1.
I was thinking.
Yes, that's what you were doing. All right, the next one, we have 3 permutation 3. So what goes in the top? 3, and then 3. And then the second number will be a 3 as well. So at the top we have 3 factorial, and the bottom, what is 3 minus 3?
0.
What is 0 factorial? 1. Do I need to write this 1 under it? No, it's not going to change anything. So now we have left is 3 factorial, which is 3 times 2 times 1, which is 6. Perfect. So these were the numbers we skipped on our exam review. So you could go back and do them. They're going to be due next week, I think. All right, so this is what your classwork will look like. In how many ways can you rearrange the letters in the word house? So what it means, you won't be able to list them because it's over 100. So please don't start trying. That means you could do H-O-U-E-S. You could spell it backwards, E-S-U-O-H. Can everyone agree that there are many ways that you could do this? So here's what we're going to do. We're going to do the permutation. Permutation, because the order matters. We've already spelled it like house, so we can't use that again. How many letters are there total?
5.
And how many of them are we rearranging? 5 of them. So 5 letters, we're rearranging all 5 of them. So in the top, we're going to have 5 factorial. In the bottom, we'll have 5 minus 5, which is, well, the top is 5 factorial. The bottom will be 1. Because 5 minus 5 is 0, factorial is 1. So then we'll have 5 times 4 times 3 times 2 times 1, which I believe we did do, is 120. So that's why you don't want to sit here and try to do it yourself, because that's too much. In how many ways can you rearrange 3 of the letters in the word March? This means you could do M-A-R, you could do M-R-A, you could do A-R-M, you could do R-A-M. You could even move on to different letters, C-H-M, M-H-C. Does everyone see? So there are many, many ways. How many letters are there total that we're picking from? 5. How many of them are we actually rearranging? 3 of them. So what goes in the top? 5, and in the bottom? 5 minus 3, which is 2. Trying to skip ahead a little bit. So the top we can make match the bottom. 5 times 4 times 3 times 2 factorial over 2 factorial. All right, so 5 times 4 times 3, which is 60. Perfect. We do 2 more together. Dos más. There are 6 finalists in a beauty pageant. How many ways can the judges choose a winner and a first place loser? Just kidding. Here we are. How many total people are there? 6. And how many places are we talking about here? 2. So in the top, we will have 6 factorial. In the bottom, you would do 6 minus 2, which is 4 factorial. So I'm doing some in my head. You can do some in your head, too. So 6 times 5 times 4 factorial. Yeah, over 4 factorial. Those cancel. So all we have left is 6 times 5. All right, we skip that. Next one, we're doing the last one. Your rock band, congratulations, has 9 songs recorded, but you only want to put 5 of them on your demo CD to hand out to local radio stations. How many possible ways could the 5 songs be ordered on your demo CD? So there are 2 reasons why this is a permutation. The order does matter, but also, if you're choosing 5 songs, would you ever repeat a song? No. You're never going to see a repeated song on a CD or on an album in general. So, how many total are we choosing from? 9. And then how many spots are there? How many places on the CD? 5. So, what are we going to put in the top? 9. And in the bottom? 9 minus 5, which is 4 factorial. So 9 times 7 times 6 times 5 times 4 factorial. So what is 9? I skipped 1. Yep. I have no idea why. 9 times 8 times 7 times 6. That doesn't look right.
60,480.
What is it?
60,480. 60480.
All right, so here's realistically what you're doing, linking to what we were doing before. How many spots are there on the CD?
9. Wait, 5.
There are 5 spots. 1, 2, 3, 4, 5. For the first spot, how many options are there? There are 9 songs to choose from. Once you use one of those songs, how many are there for the second spot? 8, and then after that? And then after that? And then after that? Doesn't this look like what we just did? 9 times 8 times 7 times 6 times 5. That's where it comes from. Do you see what I'm saying? We had 5 spots. There were 9 options for the first spot. 8, 7, 6, 5. Multiply them all together, you'd get 60,480.
Wait,
So that's what you're doing with
Yeah,
it.
that's wrong. It was
It's 15,120.
That's what I thought about.
Someone said 60,000. What is it?
15,120.
Either way, does everyone see what I'm talking about? This is where the formula came from. They didn't just pick a formula out of the top of their head. Colt, do you see where the formula came from? Noah, do you see? So re-explain it to me. So you could do one like that? Interesting. I guess we'll see.
I want to do